This is the second video in the series, Getting to Know Cimatron Die Design. Our subject today is forming and bending. If you have not yet seen the first video of this series, we encourage you to do so, as today's video will pick up where the first video left off. We will be using unbending and unfolding techniques based upon the functionality that you see listed here. Our discussion today will focus heavily on developing binders and creating blanks. Here you see the original part on the left. A form station was added from the first to become the skin. And as you recall, we're working with the die side of material, or the die skin. So we simply added another form station from the skin, given it an appropriate name, and this will be our first unfold operation. We're going to use the function called auto blank on binder. We will pick the faces that represent the binder, or what we're developing to, and then we'll pick the portion of the flange that we wish to unfold. The material properties have been stored and set up back in the first video when we selected the material. Now they're applied to create the unfold. Now those faces that had been wiped downward are developed to the binder. From here I'm going to undisplay the first form, and then from this new form we're going to add another forming station and continue our progression down the line. So again, give it the name of the next station, keep to that same progressive step over, and then we'll start working on the next form. There'll be some repetition involved in this as we keep working from one station to the next. I'm now going to create a binder to develop the rest of the flange. This will require me to use a composite curve running along the back of the flange. From there, we will use that curve to sweep faces out in the direction of the flange, basically giving it something to land on. Set it at the distance, ensuring I have plenty of room to develop toward, and then also extending the ends of this binder off so that as the flange develops upward, it has room to grow onto it. Finally, we will stitch these faces of the binder together. Now we're ready to use blank on binder. We'll simply tell the system what the binding faces are, and then pick the flange that we wish to have developed. And from there, we'll use the material properties stored and set up to accomplish this calculation. This well illustrates the power of blank on binder. Let's now give our attention to the flange on the opposite side of the part. So to do that, we will add a forming station and give that station an appropriate name for how it should appear in the strip. All these forms we will use later on as we develop the strip as well. For this flange, let's develop a preform. To do this, we will use the extend by draft angle function, which will allow us to create surfaces coming tangent off the top fillet at whatever angle we determine. So pick the angle, we'll set the distance that we want to create these surfaces. We'll also set extensions off of both ends. That way there's plenty of surface for this flange to develop to. On previewing the results, we see that the surface is cross or bow tie. A simple remedy for this is to use the patch option, pick the area in question, and then a new face will be generated in that area that's more reflective of what we want to see for this extension. These extended faces are now perfect for us to use blank on binder with. So just like before, we'll pick what we want to include as the binder, or what we're developing to. We'll pick the flange that we're working with, and then the material properties will be drawn from setup to execute the unfold. This gives us the results we're looking for in this station, with the flange preformed at 45 degrees. We will now continue on with our progression by adding another forming shape, and then we're going to use that forming shape to fully develop the flange. To do this, we will create surfaces and then use these as a binder. Throughout our progression, you can see how we're working backward through the part, unbending it a little bit at a time. The result is then that each of these progressions will be available when we assemble the strip. So as you can see, we're now at the point where we're using composite curve to grab the top edge of the flange, And then we're going to use that curve to sweep faces in the direction that we want to develop toward. Of course, we extend the ends a bit. That gives it plenty of surface for it to develop onto. As this station continues to be created, we hope that it's become evident how powerful Cimatron's die design is. With so many surfacing tools available and its powerful, robust blank-on binder development, Cimatron can meet the needs of designing even the most complicated strip. And with that, we will focus one last time on blank-on binder to finish developing the flange. So again, we pick the faces as the binder, we pick the flange, the material properties come from setup in order to do the calculation. These binding faces, they don't have to be planar or linear. They can be whatever we need them to be, which gives blank-on binder a huge amount of flexibility. We are now ready to move on to other types of bends. So we'll deal with those straight 90-degree bends in the very front of the part. With that, we add another forming shape, and we will use unbend. So with that, we pick what we're unbending to, and then the radius of the flange that we're bending. And the idea behind this is we can either send it flat, or we can bend it at an angle, maybe have this at a 45 degree for a preform. We can also let that radius float or move, so that when we come back and hit it straight down, we can get a crush on it to take out spring back. We will now repeat this on the other side. Few clicks and it's done. Simple enough. We'll give our attention now to local blank. Local blank requires working with a planar face. From there we will pick the feature that we're going to develop to that plane. And in this case, we want the system to take those rolled edges and put those in the correct position after the blank has been accomplished. So we'd see what it would look like if it was formed right to that flat plane. We have one more station we wish to create, so again we will add forming and then give it the appropriate name. And then we're going to work with this set of geometry as the next station that would eventually go into our strip. The idea behind this is to use local blank and develop it to the very top plane of the part. So again, it's just a matter of picking the faces that we're going to develop to. Like before, we wish to use those rolled edges in a different way. We want to position them as if they were struck first before we did the local blank. You get the idea, then it'll be positioned where it needs to go on top of that flat plane. Another important feature we'll look at today is blank. Blank gives the 2D profile of the part once it's been completely flattened or blanked. Of course, it also works off the same material properties as all the other blanking operations. And the idea is to get, again, that outer boundary of what the blank size would look like, whether that be for nesting or for getting wire burn data. We generated this blank after progressively unfolding the part. But that's not to say that we can't use blank immediately on a more complicated form. For instance, we'll use the skin, like before, to get the blank. And you can see how important that might be in order to get the information we need to do a good quotation. It is easy then to compare these two blanks. The idea of comparing a more progressively unfolded blank versus maybe a preliminary quick blank. And by overlaying the two, we can see how very close they actually are. Let's take a moment to review some of the important things we looked at. We saw auto blank on binder. We also took a look at how we can create flanges by extend by angles for preforms. We looked at blank on binder and saw a couple of different applications for where we can use blank on binder. We saw the ease with which we can model our own binder. We also saw straight linear unfolds. We took a look at local blanking. In fact, a couple of good examples for local blanking. Thank you for reviewing this presentation. Please look for our next video presentation, which will deal with analyzing forming conditions that create tearing and wrinkling.